Since turtles typically live decades, they would then need a way of overwintering. And so they undergo brumation, similar to hibernation in that it is a slowdown of metabolism, but they are not asleep and can be active once the temperature warms. So it's not truly like the hibernation of warm-blooded animals. Like snakes, box turtles are able to undergo brumation on land. They dig a burrow which is below the frost line, and here their metabolism slows until the temperature warms in spring. In the wild, box turtles are solitary, so they would overwinter by themselves, unlike aquatic turtles, which often can congregate in groups. Most aquatic turtles undergo brumation in the mud at the bottom of a body of water, although masses of plant material and abandoned burrows, say of a muskrat or the lodge of a muskrat or beaver, are also possible. The bottom of the pond is warmer than the frozen surface of the pond, although turtles can die if it becomes too cold, or they may seek out deeper water if it becomes too cold. In brumation, a turtle's metabolism can slow 99%. Its heartbeat can slow to the point of 8 beats per hour, and aquatic turtles have been able to live 100 days at 37 degrees Fahrenheit, the temperature at the bottom of a typical pond in winter, without any food or without breathing oxygen. To be clear, however, even though submerged turtles under the ice are not breathing oxygen through their lungs or removing carbon dioxide through their lungs, they can still perform gas exchange of oxygen and carbon dioxide. They can perform what's known as cutaneous respiration through their skin, or bucopharyngeal respiration through the well-vascularized lining of their mouth and throat, or even cloacal respiration, where they actually perform gas exchange through their cloaca, which is dilated to increase water flow during winter. The cloaca is the single opening which reptiles, amphibians, and fish possess, where the anus, the urethra, and in females the vagina empty into. Wood turtles are not as tolerant of low oxygen levels as, say, snapping turtles or painted turtles, and therefore prefer flowing water where oxygen levels are higher. And in snapping turtles and painted turtles, during brumation, they may undergo some periods of activity, so you may be able to see these turtles actually moving under the ice. The adults of the endangered bog turtle can burrow 18 inches into the mud of a bog for their brumation. Painted turtle hatchlings are a special case when it comes to adaptation for the cold. Painted turtle eggs are laid in spring and hatch in autumn. Some hatchlings leave the nest and enter the pond, while other hatchlings choose to overwinter in the nest, spend their winter there. And this can vary within a nest, where some hatchlings leave and some stay. The nest where the eggs were laid is not a burrow like a hibernaculum. It is not as deep, so therefore it's going to get colder in winter. But painted turtle hatchlings can survive temperatures up to -8 degrees Celsius. They are the only reptiles whose extracellular fluids can actually freeze. A few frogs, such as wood frogs and spring peepers, can do this, but painted turtles are the only reptile as hatchlings. Their blood, and then from the blood into the blood and cells can contain cryoprotectants, or something that functions like an antifreeze, where by adding extra components to water, the water's point of freezing is now lower. Glucose levels can increase threefold, as can the levels of glycerol. Amino acid levels can increase more than twofold, and many tissues which are now providing energy without using oxygen are accumulating lactate. And so painted turtle hatchlings are then arguably the reptiles best adapted to deal with cold.